Have you ever wondered where colors come from? Colors are, without a doubt, one of the most intriguing aspects of our world. They're everywhere, shaping our lives in ways that we may not even realize. They have the power to evoke emotion, communicate information, and create aesthetic experiences. But have you ever stopped to think about their origins? Where do they come from, and how did they come to hold such significance in our lives? Let's embark on a journey to explore the origin of colors. We'll start by delving into the etymology of color names, tracing their roots across different languages and cultures. We'll uncover the fascinating linguistic tales that have given us the color names we use today. Next, we'll venture into the realm of physics to understand the science behind colors. How do objects interact with light to produce the vibrant hues that we see? And how did a 17th century scientist named Isaac Newton help us understand this phenomenon? But our journey doesn't stop there. We'll also explore the evolution of color vision. How did early humans develop the ability to perceive and distinguish colors? And how has this ability influenced our survival and evolution? We'll then delve into the world of synesthetic experiences. Imagine associating specific colors with letters, numbers, or sounds. That's the reality for people with synesthesia, a condition that offers unique insights into the subjective nature of color perception. Our exploration of colors would be incomplete without considering their role in artistic expression. Artists have long manipulated colors to convey emotions, narratives, and moods. We'll look at how tools such as the color wheel have influenced the way colors are combined in art and design. Finally, we'll consider the impact of technology on color. From the creation of new pigments and dyes to the development of digital color spaces, technology has significantly influenced the way we perceive and use color. So buckle up as we delve into the mesmerizing world of colors. Ever thought about where the names of colors originate? Welcome to our journey into the rainbow of language, where we'll unravel the fascinating linguistic origins of color names. Let's start with a familiar color, blue. The term bleu takes us on a linguistic voyage back to Old French, where bleu was the word for this serene hue. But the story doesn't stop there. Dig a little deeper, and you'll find that bleu itself has roots in an even older language, tracing back to the Germanic word blau. Now, imagine a world without the color orange. Sounds incomplete, doesn't it? Well, until the fruit of the same name reached English-speaking lands, there was no specific word for this vibrant color. The introduction of the fruit led to the birth of the color term orange. And what about pink, a color often associated with softness and warmth? Its name comes from the delicate flowers known as pinks, part of the dianthus family, which are admired for their frilled edges that appear as if they've been cut with pinking shears. Moving on to purple, a color often linked with royalty and luxury. Its name is derived from the Latin purpura, which refers to the costly dye extracted from a species of sea snail. This dye was so expensive and sought after that only the wealthiest could afford it, thus cementing purple's association with nobility. The story of green is tied to nature. The term originates from the Old English word green, which is related to growen, the Old English verb meaning to grow. It's no surprise that green, the color of life, growth, and renewal, shares its linguistic roots with the very act of growing. The etymology of color terms is a captivating journey across cultures and through time. It offers a glimpse into the historical, cultural, and even economic influences that shaped how we talk about and perceive colors. The names of the colors we use daily have a rich history, each one telling a unique story. So next time you marvel at a brilliant blue sky or a lush green landscape, remember, there's more to color than meets the eye. But what about the science behind the colors we see? Well, it's all a matter of light and how it interacts with objects. You see, light is made up of electromagnetic waves that travel at different speeds and have different lengths. These wavelengths are what we perceive as colors. For instance, when light hits an object, say a ripe apple, the apple absorbs some of the light and reflects the rest. If the apple appears red to us, it's because it's absorbing all colors of light except for red, which it reflects back to our eyes. But that's not the whole story. The color we see also depends on the light source. If we were to look at the same apple under a blue light, it would look different because the light source is now emitting a different color of light. And what happens when light passes through a transparent object like a glass prism? Well, this is where Sir Isaac Newton enters the stage. In the 17th century, Newton conducted a series of experiments using prisms. He discovered that when white light passes through a prism, it splits into a spectrum of colors, the same ones you see in a rainbow. Newton's experiments proved that white light is actually a combination of many different colors. He even arranged these colors on a wheel to show how they relate to each other, creating the first color circle. But what about objects that emit light, like a neon sign or a computer screen? They create color through a process called emission. Instead of reflecting light, they produce it. The color of the light they emit depends on the type of gas or the properties of the screen. It's fascinating, isn't it? The colors we perceive in our day-to-day lives are the result of complex interactions between light and matter, and the spectrum of colors we can see is just a fraction of the electromagnetic spectrum. So the colors we see are really a game of light and matter. Did you know that our ability to see and distinguish colors has evolved over time? Let's take a journey back to our early ancestors. Picture them foraging in the wild, seeking nourishment from fruits and plants. The ability to discern ripe, nutritious fruits from unripe or poisonous ones was quite literally a matter of life and death. This is where color vision becomes a game changer. Over thousands of years, humans developed trichromatic vision, a fancy term for seeing in three primary colors: red, green, and blue. This evolutionary adaptation allowed our ancestors to pick out ripe fruits from the green foliage, a critical advantage in the race for survival. But it's not just about food. Color vision also played a crucial role in social interactions, recognizing flushes of emotion on faces, identifying friend from foe in varying lighting conditions, or even choosing a vibrant, healthy mate. All these aspects of human life were transformed by our ability to perceive and distinguish colors. Interestingly, our color vision isn't uniform across the board. Some people, particularly women, can have tetrachromatic vision. That's 4 primary colors instead of 3. This additional color sensitivity opens up a whole new world of hues that most of us can't even fathom. But what about those who see fewer colors? Color blindness, a condition that affects millions worldwide, can limit the range of colors a person can distinguish. This doesn't mean they live in a black and white world, but their color palette is definitely different. It's also worth noting that our perception of color is not solely biological. It's also influenced by our cultural context, personal experiences, and even our mood at a given moment. As we journey through the colorful tapestry of life, let's remember that our ability to perceive these beautiful hues is more than just an aesthetic delight. It's a testament to the ingenuity of evolution, a tool for survival that has been honed over countless generations. Our eyes have evolved to see the world in a colorful array, a true testament to nature's ingenuity. But how has technology influenced our perception of color? This question leads us into a realm of exploration and discovery that has revolutionized our use and understanding of color. From the dawn of human civilization, colors have been derived from natural sources: plants, minerals, and even certain insects. However, with the advent of industrialization and advancements in fields like chemistry and material science, the spectrum of available colors exploded. Scientists began developing synthetic pigments and dyes, some of which produced hues never before seen in nature. Take, for instance, the color mauve. Until the mid-19th century, this shade of purple was practically non-existent. That was until a young chemist named William Henry Perkin accidentally created a synthetic dye while attempting to synthesize quinine. This discovery not only gave birth to the color mauve, but also kick-started the synthetic dye industry. Fast forward to the present day, and we see technology's profound impact on color in every facet of our lives. In the world of fashion, designers can now experiment with a virtually limitless palette, thanks to the availability of a wide array of synthetic dyes. This freedom to experiment has given rise to trends and styles that define our times. Digital media, too, has been transformed by technology's influence on color. The development of color displays has allowed for the creation of vibrant and immersive visual experiences. From the captivating graphics of video games to the stunning visuals of high-definition movies, we're able to enjoy a depth and range of color that was unthinkable just a few decades ago. As we delve deeper into the digital age, technology continues to redefine our relationship with color. Augmented and virtual reality technologies are pushing the boundaries of color perception, creating immersive experiences that challenge our conventional understanding of color. As we continue to innovate, the palette of our world becomes ever more vibrant. The story of color is an ongoing journey, one that is shaped by our ceaseless pursuit of knowledge and the relentless march of technology.